I'm pleased to present my perspective article entitled Chemical Artificial Intelligence in the Limelight, the Contributions of Photochromic Materials and Oscillatory Chemical Reactions, published on Advanced Optical Materials in April 2025. Life is a genuinely mesmerizing phenomenon with many features. Through a semantically dense sentence, it's reasonable to state that every living being is a self-boundary and self-sustaining auto-thermodynamic equilibrium system which shows purposefulness. Among the four features mentioned in this definition, the fourth one, purposefulness, constitutes the focus of chemical artificial intelligence. The fundamental purposes that every healthy living being pursues are survival and reproduction. Goal-directedness is managed by living beings' power to utilize matter and energy to encode, collect, store, process, and communicate information. All living beings are information-gathering utilizing systems that show variegated forms of intelligent performances. Intelligence is like an iceberg. At its tip, there's the capability of reaching goals by learning and undertaking actions not entirely determined by local circumstances. The research line of chemical artificial intelligence is trying to answer the following heuristic questions. Which performances of biological intelligence can be mimicked through inanimate chemical systems in wet or in liquid solutions, which is the characteristic phase of life? This figure shows a programmatic knowledge map of chemical AI. It's a three-dimensional graph projected on a plane. The x-axis refers to the Chi domains, which are molecular and supramolecular chemistry, system chemistry, and multiscale chemistry. Multiscale chemistry refers to chemical systems that manifest self-organization at different spatial scales, and multi-level causality, when appropriate macroscopic thermodynamic forces are applied. Such chemical systems maintain in out-of-equilibrium conditions, originate dissipative structures and forms of active matter. Multiscale chemistry is needed to mimic the structural and functional performances of multicellular biological organisms exhibiting multiscale competencies. That means the capability of handling different types of information and problems at various spatial scales. The y-axis of the knowledge map of Chi reports the Chi paradigms, which are biological sensor, brains, and effectors. Finally, the third axis, represented by the saturation degree of the green color, reports the biological intelligent competencies, which range from sensing to perceiving, from computing to planning, from working to acting. Some of these competencies have already been implemented and are indicated in black. Others have not and are shown in white. In my article, I show the contribution of photochromic materials to the development of chemical AI. Photochromic compounds are fundamental molecular ingredients in any living organism interacting with solar radiation. Photochromic compounds allow living beings to orient themselves in space and time because they work as molecular transistors and molecular fuzzy sets. My article demonstrates different strategies for making photochromic compounds valuable for chemical AI. Photochromic compounds allow the implementation of, first, forward causality through the principle of free energy minimization across the fastest route, which is fundamental for any kind of computation in the field of natural computing. Second, final causality through the negative feedback action operating whenever a photochromic compound is pushed far from its photostationary state. And these final causalities required for molecular cybernetics. Third, circular causality that becomes a fundamental ingredient for implementing a Markov blanket. through the feedback action between any photochromic compound and its microenvironment. Fourth, basic Boolean operations and hence Turing machines through photochemionics and chaos computing. 5, chemical fuzzy sets, which are quantum mixed states, and their manipulation constitutes an unconventional form of quantum computing. 6th, neuromorphic engineering, wherein photochromes along with the oscillatory chemical reactions are proposed as dynamic neural surrogates capable of giving rise to synchronization phenomena through the communication of optical and chemical signals. So I think you will find my paper interesting. So please check out my article, and I hope you enjoy reading it. Thank you for your attention.